All right, class. So we've already covered some of this a little bit in some videos that you guys saw back before the break. But let's just pretend we're starting from zero. Zero not being a circle, but the subject of this video indeed being a circle. All right, so a few things that we need to start with. When we're talking about a circle, technically speaking, we're actually just talking about the outside of it here. A round outside curved, not a line because all lines are straight, but you know what I mean, the curved line that's the outside of it. That's what the circle is. Technically speaking, it's actually a set of points, a group of points that are all the same distance from one other point, right here, the center of the circle. So all the points that are the same distance away from the center is what makes a circle. But you guys know a circle to see, it's that round looking thing. The one point to know, just in terms of vocabulary, is that the middle of this is not really part of the circle proper. In fact, that middle part there, what you have here, is properly called the disk. So you see here, the disk is the inside of it. It's like if you think, if you sliced a sausage crosswise, then the skin of the sausage would be the circle, and all the meat inside here would be the disk. So what I'm going to do here is just, and I recommend you do this on the sheet you have there, well, I want you to do this on the sheet that you have there, color in for all these definitions so that the picture you have reflects the definition. So first off, let's say, let me get a good color here that'll show up. Let's say if I'm talking about the circle, what I mean is I want you to really, with much better fine motor control than I have, highlight the outside of it here. That's what the circle is. And when we're talking about the disk, that the disk is the inside of it there. So circle's the outside, disk is the inside. All right, so far pretty straightforward. Now, when you're talking about the radius, and this I know we talked about a little bit, or you watched videos about it back before the break, the radius is, if you think of it, it sounds a lot like the word radar, and you think the way those radar things look in the movies. It's always this arm sweeping around in a circle like that. The radius is just any line you get when you start from the center of the circle and you go out to the edge. Okay, now you see the way I've drawn it here is not very good, so I'm going to draw it much better because a radius is going to be straight like that. Right? Like anything like this would be a radius. Okay, so here's a radius just like that. Now a tangent, this word comes up a lot, and you'll see that it's very important when you get to secondary 4. We won't use it a whole lot now except in setting up word problems. But a tangent is a line that intersects, that means crosses a circle at one point only. So you might think, well, I don't know what that means. Like if I do this, isn't this a line that intersects a circle at one point only? Well, technically no, because a line is something that goes infinitely in both directions. So a line like this would actually, would cross over the circle at 2 points. That means this is not a tangent. So you're saying to yourself, well, how can I draw a line that only connects with the circle once? That's actually seeming pretty impossible to do. But I'm sure some of you guys might have figured this out. The way you can have it intersect the circle at just one point is if it just hits the edge of it right at a point there. You see like that? In this case, this line here is tangent to the circle because it only connects at one point here. In fact, one way you could think of it is you could say, like, let's say I have a basketball sitting on the gym floor. Then it's almost like the basketball is tangent to the floor of the gym. Not exactly if we get into the physics of it because the basketball is in a perfect sphere, but that's kind of how you can think of it. Tangent just means a line that intersects a circle at exactly one point. So make sure to draw this line in on your diagrams. All right, moving a little further down the page, you see it says central angle. So a central angle, the name is kind of helpful because it's an angle at the center, right? And if you think, well, if I want to make an angle, then I need to have two lines that the angle is between. And those two lines, since they both touch the center, they're both radiuses. Or actually, if I'm going to be proper here, the way that you say more than one radius is radii. Okay, so if I have two radii, then the little angle that is formed between these two radii is the central angle. So that right there is your central angle. Now technically there are two central angles here, right? Because there's an angle here, looks like it's maybe about 70 degrees between these two radii. there's also an outside angle like this, right? This outside angle could be about, I don't know, 290 degrees, we could say. So you've really got two central angles, but usually we're referring to one, and most of the time, unless I say otherwise, I'm referring to the smaller one on the inside here. But that's your central angle. An angle right at the center of the circle. It's an angle formed by two radii, just like it says up here. Okay, so a sector. A sector, one way you can think of this is you just imagine yourself walking down the street. Let's say you're in Brooklyn, New York, and you happen to notice a sign for a restaurant, Hector's Pizza. Okay, think of Hector. You can probably think of some guy, maybe he's got a mustache, a great flair for flavor, knows some good toppings to put on his pizza. All right, I want you to think of Hector's Pizza because a sector, which rhymes with our friend Hector, a sector is really just a slice of pizza. Okay, a sector is part of the disk of the circle, part of the inside, and it's what's formed is the area between two radii. So if you have two radii, then the area in there is the sector. Remember Hector and a slice of pizza? Sector is just a slice of pizza. Notice a sector is going to have an area, right? And we'll come back to, it's got a buddy down here, arc, which is very closely related. But sector is the area part. It's like the chunk of the middle. It's the slice of pizza, Hector's Pizza. All right. A chord now. A chord, we talked before about how a tangent intersects the circle at only one point. But any line that connects one side of the circle with the other side, like that, is a chord. Notice it says a segment. It doesn't say a line, because if it were a line, and like I said, a line has to go infinitely in both directions, that would be a line. If I'm saying just part of a line, which is often what we think of when somebody says line, it's actually a line segment. In this case, it's a segment joining any 2 points on a circle. So whenever you've got a line that joins one point on the circle to another point on the circle like that, that's a chord. Here, I'm going to draw another chord for you. Here's one like this. That's also a chord if my segment is exactly on the edges of the circle here. I could have a chord going diagonally across like that. That would be a chord. Or going the other way. Like that, I could have a chord. Now you might be saying, well, is it possible to have a chord that goes right through the middle of the circle like this, right through the center? The answer is yes. And it's a diameter. A diameter is just a specific kind of chord, right? These two here are actually like you could say like chord. You know how you say like, well, all squares are rectangles, but not all rectangles are squares. Well, all diameters are chords. Not all chords are diameters, right? So here, this thing here, this fits the definition of a diameter because it passes through the center of a circle. It's a line segment connecting one side to the other. But it also fits the definition of a chord. It's a segment joining any 2 points on the circle, this point and this point. See, like here, I can have chords that are not diameters, right? Like these things are chords. They're fine. There's nothing wrong with them. I can even have 2 chords intersecting each other like this. But if I want to have something called a diameter, then it really has to be one that goes through the center of the circle, right? Just like we saw the radius did before. And in fact, you can always get 2 radii out of any diameter just by chopping it in half, which means chopping it right at the center. Now I mentioned before that a sector up here is a slice of pizza, right? Arc down here is, you can think of it as like the pizza crust, okay? Because if this whole chunk here with all the cheese in it is Hector's Pizza, then the arc is just the outside of the crust, right? And it's defined by a chord or 2 radii. That means that if I have 2 radii, well, let me get a line in here, it'll be better. If I have 2 radii like this, then they can tell you exactly where your arc is. It's this part here. Or you could just have a chord going through the circle like this and say, okay, the arc that's defined by this chord is the part of the circle, the part of the edge that connects those 2 points going over the edge of the circle. So arc and sector are very closely connected, right? You could say to yourself, if I have a situation like this, then the in part here, the cheese part, that's my sector. And the crust out here, the part of the circle that's going around like that, that's your arc. And one way you could think of it is arc, right? If you think to your French, right? What is an arc? You can think of an arc-en-ciel, that's a rainbow, right? Or you could also think of the sport of archery. Is tir à l'arc in French. And that makes sense because if you think of the old bows before we got more complicated, you think of a bow is really just a cord, which is the string of the bow. So that's why you can think of that's why it's called a cord, as well as the wooden part of the bow, which is out here. So if I think of a bow, then I know this part here is my arc, my tir à l'arc. It's the bow part. And the string part makes sense that would be the cord. So here I've got an arc and a cord. So that's my arc is the curvy part, and my cord is the straight part here. Right? Here I've got a bunch of chords without saying specifically that I've got some arcs, but here I've got an arc and a cord. Most of the time, you'll see in the problems that we use, in the word problems that we use, we have chords connected with two radii. Right? Like it says here, a part of a circle is defined by a chord or two radii. Because you'll see one of the formulas we use a lot when we're dealing with arcs has to do with that angle that's formed between the two radii, which once again you'll remember is called the central angle. So the angle that's formed by the two radii is going to be very closely connected with the length of the arc. You'll see that formula when we get to it. All right, now if you flip over the page,